Okay, welcome back. Hope that port mirroring lab went okay. Here we are in the storage scalability module. We will talk about quite a few different topics as they relate to scaling your storage. For instance, the scalability features in the software-defined software configuration allow your vSphere environment to handle growth efficiently in your environment. For data store growth and expandability issues, you need to or can use features such as storage DRS, and knowledge about all these different things that we'll be covering are an essential part about any large-scale storage infrastructure. So let's take a look at what lessons we have here. Now, as you can see, we have 9 lessons as they relate to quite a few areas in storage. It all starts off with the VMware file system. While this is not needing to be an introduction to the VMFS file system, but just understand what are the scalability features, and also some notable distinctions between the latest versions of VMFS compared to the traditional VMFS version 5. We'll also take a look at APIs. There's several APIs that we'll cover here, some of which have to do with hardware acceleration on the storage side. Others relate to having the storage advertise the storage capabilities back to vSphere. We'll show storage policy-based management, understand what that is, and how it relates to managing our data stores and how the storage policies can manage our APIs as well. So we'll discuss storage policies for traditional storage. We'll look at storage policies for vSAN storage and storage policies for virtual volumes. Next up, we'll look at storage I/O control. Much like network I/O control, it's a way of prioritizing our storage I/O when you have multiple ES6 servers trying to access the same data store. And finally, using storage I/O control in a data store cluster, leveraging storage DRS. So without further delay, let's begin our first lesson here, the VMFS data store topics. So like I said, this is really just understanding some of the basics, well, not the introduction, but some of the basics of understanding the scalability features of the VMware file system. And especially how storage relates in vSphere, as well as can leverage the features in VMFS. We'll explain why VMFS is a high-performance scalable file system, identify the performance improvements that have been made with VMFS 6 over VMFS 5, and describe the migration procedure if you needed to move your virtual machine files from a VMFS 5 data store to a VMFS 6 data store. All right, so as you all know, VMFS is a high-performance cluster file system optimized for large files. Lots of file systems are designed to handle different types of file management, right? Some file systems are designed to handle large files. Some file systems may be designed to handle lots and lots of little files. VMFS is really geared towards those large files, such as virtual disks, vSwap files, and also, while at the same time being able to adequately handle the small files, like the VMX and the BIOS files that aren't so big. So we need a file system that actually handles a bit of both. Also, whether you have thick disks or if you have thin disks, how is the performance difference there? So we need a file system that can cater to all types of files, essentially. And so there's been some interesting enhancements in vSphere 6.5. We now have both VMFS 6 and VMFS 5. And in vSphere 6.7, another change, whether that any old data stores you might have from VMFS 3 days. Now that goes way back to the old ESX3 and ESX4 days. If you happen to have any of those old data stores, they're not supported in vSphere 6.7. So if you try to mount a VMFS 3 data store, guess what happens? It automatically gets upgraded to VMFS 5. Not 6, but it goes to VMFS 5. We'll show why here in a few slides. So both VMFS 5 and VMFS 6 are both highly scalable. What does that mean? They can both support your LUNs up to a size of 64 terabytes, right? The max data store size, the max single extent size is 64 terabytes. Sure, you can span multiple extents or expand multiple LUNs into a single logical VMFS data store. However, the largest size data store is still 64 terabytes, and therefore also the largest size LUN or extent is also 64 terabytes. So you can't span two 64 terabyte LUNs into a single logical data store, though. You could only span together two LUNs that together added up to 64 terabytes. That's what's the max supported data store size. Also, the largest file size is 62 terabytes. Your virtual disks, of course, would be the largest size, being 62 terabytes. Now, also worth noting, the file system block size is 1 megabyte, supporting our files up to those 62 terabytes. And in order to prevent from wasted space, those 1 megabyte size blocks can also be broken into what are called subblocks to efficiently store lots and lots of little small files. So imagine if you had a VMX file, which is really just a couple kbytes, to have that sit as the only file in a 1 megabyte block, and then another little tiny VMX file sitting into another 1 megabyte block, that would be very wasteful on disk space. So a 1 megabyte size block can fit literally thousands and thousands of little files, all broken into what are called subblocks. Now, as far as placement goes, there's also a new algorithm starting in VMFS 6 that uses what we call small file blocks and large file blocks. Those aren't the file system blocks per se. Those are just the allocation processes. And the large file blocks are 512 megabytes. Those are used extensively for the thick disks. And then thin disks, which are much, much smaller, just 1 megabyte, these small file blocks, are the allocation process for handling in the placement of the thin disks as they are growing over time. And also worth noting, for scalability purposes, any virtual disk now can be hot extended from less than 2 terabytes to over 2 terabytes, all the way up to 62 terabytes. So that's actually a leftover fragment from when we first started supporting 62 terabyte size files. That was back in vSphere 5.5. when we just started supporting the 62 terabyte size files. But at that time frame, there were still plenty of operating systems with their file systems that weren't supporting the hot extension of their own partitions from less than 2 terabytes to over 2 terabytes. Back when we did change from 2 terabytes to 62 terabytes, that was back from changing from vSphere 5.1 to vSphere 5.5, right? vSphere 5.1, the largest file size was 2 terabytes. vSphere 5.5, the largest file size was 62 terabytes. However, at the vSphere 5.5 timeframe, vSphere did not allow you to hot extend a virtual disk over 2 terabytes. So growing from less than 2 terabytes to over 2 terabytes, or once you were over 2 terabytes and needed to grow to another size beyond that, that could only be done when the VM was powered off, having to do with protecting certain guest OSs that didn't support that hot extension as well. However, in vSphere 6.5, the vSphere restriction was lifted, so now vSphere allows hot extending virtual disks from 6.5 and onwards, no matter whether you're less than 2 terabytes or over 2 terabytes. Now, if the guest OS has issues with that, you have to be mindful of the guest OS. The restriction in vSphere is what has been lifted. Now, VMFS data store improvements, right? If we were looking at that previous slide, everything was basically saying, oh, VMFS 5 and 6 have a lot of common characteristics, right? That's that slide. This slide is what's new with VMFS 6. Of course, this is what was introduced in vSphere 6.5 when VMFS 6 was released. Effectively, what it does is it has faster file creation times and has improved parallel disk operations and concurrent transactions. Basically, under the hood, VMFS 6 will outperform VMFS 5 in several areas. One of which is this neat new capability of having the small file blocks and the large file blocks. The small file blocks for handling the thin disks, and the large file blocks for handling the larger virtual disks and the thicker disks, or the thick disks. That has in itself made the file creation time far, far faster for all kinds of disks, particularly with the thin disks though. And then with the parallel disk operations, there's been improvements in the atomic lock handling, in which how file locks occur and when VMs are powered on and anything that involves file locking. That has had a major improvement in how we do parallel disk operations, concurrent transactions. Where this is even more prevalent is whenever there's ever any kind of LUN resignaturing handled by Set Recover Manager. That could have been a time-consuming process. This is much, much faster with this new improvement in lock handling with VMFS 6, starting in vSphere 6.5. Another new feature introduced in vSphere 7, actually two new features introduced in vSphere 7, are now we have the support for creating a shared virtual disk. This is a big change from the past where you could have a multi-writer file, but here we actually have a proper virtual disk that can be shared between two different VMs on two different ESXi hosts. Now, there are some hardware requirements here. You do need to have SCSI-3 persistent reservations capable at the hardware level. This is actually only supported on fiber channel storage also. But where this is really very useful is if you have a Microsoft failover cluster, where traditionally that shared data disk would have been a raw LUN. Now you can do this with a shared virtual disk. So that's the significance, right? It can support clustered virtual disks on specific data stores. As we mentioned, needs to be supported hardware here, mostly that it's fiber channel with the SCSI-3 persistent reservations capabilities. There's also some other restrictions, right? You can't snapshot the VM, for instance. That's another issue, but that's also issues you have with raw LUNs. But here you don't need to worry about having to create the whole raw LUN. We can just do all this with a shared virtual disk. And you can also take the vSphere client to migrate any of the raw LUNs that you are using with raw device maps and migrate them to a VMDK file format. Basically, you do a storage migration, like a storage vMotion, and when you go through the wizard, select that you would like to move data at the disk level, where it will then prompt you to move your data from a raw disk format to a virtual disk format. And then another interesting feature added in vSphere 7's VMFS 6 is this, what we call the Affinity 2.0 Manager, designed to be smarter and more efficient in the allocation of resources for thin disks. So this is improving your performance on thin disks. Traditionally, what happens is when a thin disk gets created, each of the different file fragments need to be placed out in the data store somewhere. So there's actually a fair amount of back and forth between the drivers within the file system to find the file location. And that overhead was basically trying to find the correct location, just going out to the data store and say, hey, is there space here? Is there space here? Essentially, the file system is broken up into what are called resource clusters of a set of sectors that are usable for things like thin disks. And there is always go out and find the free sectors, go fetch those free sectors, and then go ahead and start allocating them. With this new Affinity 2.0 Manager, now these resource clusters are now organized into what are called region maps held in a cache. So now the Affinity Manager can quickly find the status of each of the different resource clusters without having to go and fetch that information. It already knows this information right up front. It knows the size and the capacity and the availability of each of the different resource clusters. So thin disk fragments can be placed very efficiently without the overhead that they've had in the past. So that was a quick look at some of the comparison between VMFS 5 and VMFS 6. Some of the changes from vSphere 6.5 up through vSphere 7. We'll take a break right here. We'll come back and take a look at some vSphere specific storage characteristics going through the different versions of vSphere. So we'll see you right after the break.